So do you get confused between covariance and correlation? Want to know the difference between them? Then stay tuned, as in this video I am going to explain you 5 points that will clear out your confusion, where point number 2 and point number 4 are the most important points from getting misleaded. But if you miss out point number 5, you will always be confused between when to use what. So make sure you don't miss any of the points, and without wasting any time, let's start with point number 1. What is covariance? Covariance is a statistical measure that quantifies the degree to which two variables change together. In other words, it helps us understand whether the variables move in the same direction or opposite directions. The positive covariance means that as one variable increases, the other tends to increase as well. On the other hand, a negative covariance indicates that when one variable increases, the other tends to decrease. For example, if we have data on the number of hours spent studying and the corresponding test scores for a group of students, positive covariance would suggest that students who study more tend to score higher in the test. Let's see how to implement it. So as you can see on the screen, I have two arrays. One consists of the students' study hours and the other array consists of the scores of the students in the test. So let's find the covariance between them. I will write cov is equal to np.cov study hours, test scores. And if I print cov, I get a covariance matrix where the second element is our covariance between both of these arrays and the diagonal elements are the covariance with themselves. So we will be needing the second element, so I will fetch it using 0, 1 and I can get the covariance. Now is the time to understand one of the important points, that is point number 2. What is the problem with covariance? So if you have noticed that while taking covariance, there wasn't a fixed range of values, that can be challenging to interpret how strong our relation is between the features. Now that's where correlation comes into the play. Point number 3. What is correlation? Correlation is more widely used and standardized measure that captures the strength and direction of the linear relationship between two variables, and it ranges from -1 to +1. A correlation of +1 indicates a perfect positive relationship, -1 indicates a perfect negative relationship, and 0 indicates no relationship. Let's head to the screen and see how to find the correlation. So we will be using the same arrays, study hours and test scores. So to find correlation, I will use np.correlation coefficient, that is corcoef. Pass both the arrays, study hours and test scores. And I get the correlation matrix where the second element is our correlation. So I will fetch it out. So I get 0.93 as a correlation between these arrays, which is close to +1. So we can say it is a positive relationship. Now it's the time for point number 4. Correlation doesn't imply causation. Now what is it? So it means just because two variables have a strong correlation, that doesn't mean one causes the other to change. There might be other underlying factors, or it could be a mere coincidence. So when should we use covariance or correlation? And that is exactly our point number 5. If we are interested in the strength and direction of the relationship between two variables and want to compare the different datasets, correlation is the way to go. But if we are specifically interested in the degree of change between two variables without any range of values, covariance can be useful. I hope your confusions are cleared, and if you are confused between percentage and percentile, click on the video to the left, and want to learn about various measures of dispersion, click on the video to the right, and I will see you there. Till then, keep learning and thanks for watching.